Hi everybody, this is Mrs. Lehman. I hope everyone is doing well. I am at school, but I am not obviously in the classroom. So you have virtual Mrs. Lehman walking you through lesson 10, writing and interpreting inequality statements involving rational numbers. So the first thing we're going to do is take some notes. Now, if you could flip to your note section in your module, that would be great. I'm going to attempt to write on this. All right, here we go. So in the note section, our topic is inequalities. So inequalities. All right, so we know what an equal sign means, right? That's equal. Nothing new there, right? So an inequality does not have an equal sign. All right, so what signs would we see in an inequality? Well, I bet you've already learned this. Greater than is one that you should know. Greater than. And then we would have less than. Now you guys are probably familiar with these. In an elementary school, your teacher probably drew these, with the little teeth, right? And so it was a number monster that, ate the biggest number. I've also heard the another way of remembering it, which would be that it points at the little guy. So, that kind of seems like a little bit of bullying, which I'm not into. So we're going to just go with eating the bigger number, which seems way less cruel. Anyway, so greater than, the mouth of that opens up to the bigger number, and less than, it points at the smaller number on the left. So you read these left to right, okay? So, for example, we would have something like 7 is greater than 6. Or we could write it in the other direction, and we would read it 6 is less than 7. All right, so either or would express the same thing. And that means, the number 7 is bigger than 6, and 6 is smaller than, right, 7. So those you probably already know, okay? Now, in 6th grade, we do not, unfortunately, hate to break this to you, we do not use the number monster, number alligator teeth. We have to, draw the tooth loss version of that. So, anyway, equal, greater than, less than. All right, so here are the ones that you did not know about, I don't think. This symbol right here. So that symbol with a line under it, it looks a lot like greater than, but it also looks like equal. So this one means greater than or equal to. So when in the world would we use a situation where, like, you would never say 7 is greater than or equal to 6? I mean, yes, technically that's true, but why would we say that's equal to when we know the number? So we are going to talk about times when we use this in algebra, when we're talking about some unknown quantity, or a quantity that could vary or change. So we'll talk about that in a second. So greater than or equal to, I bet you can't guess what this one is. Less than or equal to. Alrighty. So there you have that. Those are our notes for today. So again, these are inequality statements. I'm going to give you an example of where we would use a variable. So really what's new for this in 6th grade is that we're going to use some unknown situations. So let's say to ride a roller coaster, a specific ride, you need to be greater than 48 inches tall. You have to have a height greater than, I should say, or equal to in that case. So you have to be at least. So you would say your height has to be greater than or equal to 48 inches. So if you are not 48 inches, if you're even a tiny bit below 48 inches tall, you're not getting on that ride, right? In New York State, for example, you have to be at least 16 to get a learner's permit to drive. So your age, I'm going to use A, your age has to be greater than or equal to 16. So you could be 45 just getting your learner's permit, and that's fine, but you could also be 16 years old and get it that day, right? The day you turn 16. So that could vary. That could be different for different people. So anyway, that's where you would use that. Those are greater than or equal to examples. So let's use one where you would use a less than or equal to. So let's say you go to the movies, right? And to get in as a child, it used to be 12. I'm not sure what it is now, right? Let's say your age has to be less than or equal to 12. So 12 and under, right? So you could get the child tickets for 12 and under. So your age has to be less than or equal to 12. Maybe ordering off the kids menu, they say your age has to be 10 and under, right? So at most you could be is 10. So your age has to be less than or equal to 10. All right, so some of the words that we would see there, so greater than or equal to, we might see at least, because they gave us the lowest possible amount, right? And we want anything bigger than that. Where less than or equal to, you might see at most. All right, another word you might see is minimum for greater than, right? So you'd have to be a minimum of 16 to drive a car, right? And the other one would be, let's see, maximum over here. So we'll talk about those more a little bit more. So this is going to be day 1 of 2 of this lesson. So let's go back to the note pages. Might take me a second to get there, but go ahead and get there, please. Maybe I have to click done. Yep. All right, now I scroll back. We are going to be on page 36. Now let's see if I can get that writing up here again. Oh, I think I gotta go up here. Hold on. Oh, there we go. Okay. Woohoo! So, bear with me. This is my new adventures in iPad screen recording and actually writing on the screen with my Apple Pencil. So I'm pretty hyped. But anyway, all right, it says the amount of money I have in my pocket is less than $5. So it cannot be $5. It's got to be less than 5, but greater than 4. So it could be any number in between, okay? It could be a fraction of a cent, but it's somewhere between 4 and 5. It's got to be greater than 4, less than 5. So one possible value for the amount of money in my pocket is, you know, we could say it's $4.85. Right? You could have that. Could you have 5? No. Could you have 4? No. Could you have $4.85? Sure. I'm sure you're thinking of a different number in your head, and that's fine. Right? Write an inequality statement comparing the possible value of the money in my pocket to $4. So we don't know how much money any of us could have if we had between $4 and $5. We could have varying amounts. So because we're going to use varying amounts, we're going to write a letter that represents our unknown, right? So the money we'll say is M. So money has to be greater than $4, right? And for the next one, we're going to compare the possible value of the money in my pocket to $5. So the money in my pocket has to be less than $5. And you read these left to right like you'd read a sentence. So money, or M, we would just say M is greater than 4. M is less than 5. Now, could we put these two together? Yes, we'll talk about that in a bit. But you could say, all right, we have our money amount, right? and we're comparing it to 4 and 5. So in the past few lessons, we worked on ordering integers. We worked on ordering all the other rational numbers, so decimals, fractions, and putting them in order from either least to greatest or greatest to least. And why did we do that? Well, one important thing that we're going to do with that info is write these inequality statements. So we know if I write it least to greatest, right, for my money, 5, we went from least to greatest. We're going to write less than and less than. Now, you don't ever want to have these inequality signs being like, you would never write something where it's like that. Okay, that's bad. All right, so don't write that down. Hopefully I deleted that before you had a chance. You want these, like, here's the less than sign. It's pointing in the same direction, right? Here's this arrow over here. So that's how you want it to be, okay? We'll talk about that more later. Don't stress about it. This right here is really what I wanted you to focus on. So let me undo that. All right, graph your answer from the opening exercise, part A, on the number line below. So part A says one possible value for the amount of money in my pocket. Well, way to go, Mrs. Lehman. You had to pick something complicated. All right, so let's see how many spaces we have to work with. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps. So I'm going to start down here at $4. I'm going to make this $5, right? And we know in the middle would be $4.50. Now, I could label every line, but common sense tells us that every jump is worth how much, guys? You got it, 10 cents, all right? So we've got to put this money amount at $4.85. So go ahead and do that. So 460, 470, 480, and we got to go halfway between here, right? So that is where we would plot $4.85. All right, so also graph the points associated with 4 and 5 on the number line. Well, kind of already did that, but let's draw dots there. Now, actually, I'm going to have you draw something other than dots here, just to get you, well, I was going to get you in the habit, so I'll show you here in a second. So this is what you're going to draw right here, okay? So we have the 3 dots plotted on here, the points. We know our minimum values for our maximum is 5. So what you are going to learn in a little bit, again, not right this second, is how to graph these. So I'm going to show you. All right, so you guys keep what you have in your module. I'm going to erase this. You are not to erase this. All right, so I'm just going to do this. You're not. All right, and here we go. So let's give this a try. So we know our money cannot include $4 because it's greater than $4. So I'm going to put an open circle. And down here at 5, it can't include 5, but it could literally be anything in between, right? So what we're doing here is graphing that inequality, because our money could be anywhere from just a tiny bit above 4 to just a tiny bit below 5. And how we would write that algebraically is what we already did up here. So 4 is less than the money, which is less than 5. Or we could do it the other way. We could say 5 is greater than the money, which is greater than $4. So when we're going least to greatest, we use less than signs. And when we're going greatest to least, we're using greater than signs. Okay? But we don't mix greater than and less than signs together in the same inequality. Okay? All right, so it says for number 3, let me undo this. Although I shouldn't, because that's way better. Let's see, right there. Explain in words how the location of the 3 numbers on the number line supports the inequality statements you wrote in the opening exercise, parts B and C. write one inequality statement that shows the relationship among all three numbers. So write this down, all right? Make sure you have this written right there. That's where it goes. All right, so our amount of money, right, was both greater than 4 but less than 5. So we'd say 4 is less than the money, or M, which is less than 5, and 5 is greater than M, which is greater than 4. All right, we are going to move to the next page. Let's see if I can do that. Let's see. Hey, I did it. Aren't you proud? All right, here we go. Let's try this. Okay, the next one, it says, writing inequality statements involving rational numbers. Write one inequality statement to show the relationship between the following shoe sizes, 10.5, 8, and 9, from least to greatest. All right, so this should be pretty easy. We would just put three numbers in. So we would have 8, 9, and 10.5, right? If we're going from least to greatest, obviously. So now we're comparing these. 8 is less than 9. 9 is less than 10.5. Right? It would also be accurate to list them greatest to least. So we would have 10.5, 9, and 8. And we're going to say 10.5 is greater than 9, which is greater than 8. And if you're writing them in order from least to greatest or greatest to least, either or, that's going to be perfect so that you make sure all of the inequality signs are pointing in the same direction, okay? So don't get yourself into a pickle, right? Those are usually a little sour. Anyway, Mary is comparing the rainfall totals for May, June, and July. The data is reflected in the table below. At least they're not talking about snow, right? Fill in the blanks below to create inequality statements that compare changes in total rainfall for each month, the rightmost column of the table. So they want us to focus here. And why they're telling you that is because they already did some of the math for you here. If you went from last year in May getting 2.3 inches of rainfall to this year getting 3.7, right? Oh, I'm sorry. They have that weird. Okay, take a look at that. So we've got last year here and then this year. So I guess I should pay attention, and you should too. So if we're going from last year, we're going from 37 to 23. 37. What am I doing? All right, let me start over. If we're going from 3.7 inches to 2.3 inches, that's a difference. It dropped 1 4/10 of an inch, right, between those 2 years. Versus in June, the rainfall went up. Last year was 3.5. This year it's 3.8. So it went up 3/10 of an inch. And then 3.2 to 3.7, that's an increase of 5/10 of an inch. So anyway, here we go. Write one inequality to order the changes in total rainfall from least to greatest. All right, so we're again focusing on this column, right? So the least, the lowest, or the greatest decrease, right? With the lowest number would be negative 1.4, right? And then we'd have 3/10. And then we'd have 5/10, right? So we're going to say 1.4 is less than 3/10, which is less than that. That's how we would write those numbers. So then over here, I'm going to just draw that squiggly to write my next one. From greatest to least, so you're just going to reverse that order. 0.5 or 5/10, 3/10, and negative 1.4/10. All right. Negative 1 4/10, I should say. All right, so 5/10 is greater than 3/10, which is greater than 1 4/10. All right, so notice when we went from least to greatest, we used less than signs. When we went from greatest to least, we used greater than signs. Okay, in this case, does the greatest number indicate the greatest change in rainfall? So we said 5/10 is greater than 3/10 and negative 1 4/10. which year had the greatest change, right? Or which month, I should say, which month out of these three right here had the greatest amount of total change? Well, this is kind of leading you into a concept we're going to learn after inequalities, which is absolute value. So even though negative 1 4/10 is the lowest number, it is the one with the least value, it has the greatest absolute value, meaning it was the furthest from zero. It was the greatest amount of change, whether it be for the positive or negative. In this case, it was a decrease in rainfall. That represented the greatest overall change. Okay, so does the greatest number indicate the greatest change in rainfall? No. Negative 1.4 was the greatest change overall. Right, so we'll talk about that. It has a bigger magnitude, but again, we will talk about that later. So let me try to go to the next page here. Okay, so it says exercises 5 through 8. We've got a bunch of examples here, and then we've got this lesson 9 in the problem set. So let's go ahead and try to get a few of these done before I set you loose on some other work. So question 5, exercise 5, says, see if I can get the pencil going here. Nope. That'd be lovely. And then you wouldn't have to do anything. Nope. Okay, so let me try that again. Okay, this is a real downfall of this. Where do I put add? Cancel. That's my living room. All right, let's try. All right, well, what if I just start writing on it? Oh, there we go. Okay, technical difficulties. All right, Mark's favorite football team lost yards on 2 back-to-back plays. They lost 3 yards on the first play. That's probably something worth underlining. They lost 3 yards on the first play. They lost 1 yard on the second play. Write an inequality statement using integers to compare the forward progress made on each play. So if you lost 3 yards, right, what would that be as an integer? -3, right? And if they lost 1 yard, that'd be -1. So we want to write an inequality statement using these integers. So we could either put the -3 first or the -1. Let's just go ahead and put -3, and we're comparing that to -1. So which one is greater? Well, we are going to say that -3 is to the left of -1 on a number line, so that's less than. So -3 is less than -1. Pretty easy. All right. Sierra had to pay the school for 2 textbooks that she lost. One textbook cost $55 and the other cost $75. Ooh, I bet her mom was mad. All right, so one textbook cost $55, the other cost $75. Her mother wrote 2 separate checks for each expense. Write 2 integers that represent the change to her mother's checking account balance. All right, so if it's going to cost her mother $55, so that's going to be $55 withdrawing from her account. So that's -55. And this next one, $75, so that's -$75. The impact is -75 on her account. So write an inequality statement that shows the relationship between these two numbers. So let's compare -55 to -75. Right? So -55 is less than, oh, I'm sorry, not less than, erase. Okay, try that again. All right, -55 is going to be to the right of -75. Right, so -75 is greater than -55, so we would write -55 is greater than. I hope I just said that right. I don't know. So negative 55 is greater than negative 75 because negative 75 is to the left of negative 55. It is definitely more debt than negative 55. Okay? All right, Jason ordered the numbers negative 70, negative 18, and negative 18 and 5/10 from least to greatest by writing the following statement. Negative 18 is less than negative 18.5, which is less than negative 70. Well, is that true? What do you guys think? No, it is not true. Explain. So here, we're going to use a number explanation. So negative 70 is by far the lowest number, right? That would be furthest left. So we would say negative 70 is less than, the next lowest would be negative 18 and 5/10. And then the greatest one of those would be negative 18. So there you have it. Negative 70 is less than negative 18 and 5/10, which is less than 18. Negative 18. All right. Pardon me. All right. Write a real-world situation that is represented by the following inequality. Negative 19 is less than 40. Explain the position of the numbers on the number line. All right. So we're going to skip that. But you could come up with some situation like the temperature dropped 19 degrees and another week in the summer, it increased 40 degrees. I don't know. You could compare that way. You could talk about money, how somebody lost $19, but they gained $40, right? And there you go. Let's see if I can get to the next page. Okay, look at the following two examples from the sprint. All right, what else do we have to do? Oh, these are easy. Okay, so here's what I want you to do. What you're going to do is this section right here, 1 through 6, all right? And then 12 through 15, where you are picking either integers or rational numbers, meaning it could be decimals. Obviously, in this case, if you're picking numbers between 15 and 16, it'd have to be decimals or fractions, right? And complete 1 through 6 and 12 through 15 right now. And if there's anything extra that I need you to do, I will let Mr. Aubin know. So please go ahead and get started on that. Guys, have a great day, and please be nice to those people around you. And I will see you tomorrow.